friends, today I am going to explain projection of solids. In the last video we discussed about projection of planes, but here we are going to discuss about projection of solids. First we know what is solid. Solid is a three-dimensional object which is having a length, breadth and thickness. It is called as solids. Here you can see, you can observe these are the different types of solids. And in the solids mainly there are two categories. One is a prism and pyramids. Actually this solid is called as an polyhedron, and these are the two types of polyhedron. One is a prism and pyramid. So first one is prism. Prism means it is having two faces. One is an bottom, it is called as a base, and the top one is called as a top face or top and bottom end. And these two are interconnected with the rectangular faces. But in the pyramid you can observe only it is having one base, and at the top it is having only one point, that is called as apex. It is called as apex, and this apex and base are interconnected with the triangular faces. And these are some examples. And this is a square, a prism, and it is called as a triangular prism, pentagonal prism, and square and hexagon. And it is an pyramid. So pyramid again, triangular pyramid, pentagonal pyramid, square pyramid, hexagonal pyramid. So prism is having a base, I already told that, top face, hexagonal, so rectangular faces, and these are the edges. It is a long edge, and this is called as a rectangular face. And in the pyramid it is not a rectangle, it is a triangular slant face, and it is called as a slant edge. It is called as a slant edge, and it is a slant face or triangular face. And apart from that, there are some regular polyhedrons. That is a cube. Cube is having 6 faces. That's why it is called as a cube, and it is having an equal. All the faces are equal. But in case of in prism, all the faces are not equal. Only opposite faces are equal. But in the regular polyhedron, all the faces are equal. And another example, cylinder, and one more is cone, and it is tetrahedron. Tetrahedron means it's having 4 faces. Some of the important points to be remember while solving the solid projection of solids. First thing, you have to identify the read the problem and identify the which plane is given. So which plane is given, whether it is in whether the plane is belongs to the square, rectangle, pentagon, hexagon. First thing, you have to identify the plane. Second thing, you have to identify whether it is a prism or pyramid. And the first position, always it is resting on HP. So we know that in the previous, either it is resting on the VP or resting on the HP. But in solid, always it is resting on HP. On horizontal plane only, the solids we are going to place it. Example, you can take the example of your table. Okay, so table always placed on the floor, not placed on the wall. So means the solids always placing on the HP. So here always resting on the HP. So you have to first draw the top view first, then go for the front view. So in the top view you have to write the plane. So which plane, whether it is a square plane, rectangular plane, or whether it is an pentagon or hexagon. First you have to write the plane and go for the prism. That is front view, it is appears a prism or pyramid, and in the top view it is appears regular plane. And after that you have to see whether it is an edge condition or corner condition. First thing, always it is resting on a HP. So for top view you have to write first. We have to begin with the top view. And second thing, edge condition or corner condition. And after that, second position, always inclination with the second position, always inclination with the HP position, means horizontal plane. And third position is VP inclination. See, this is one example I written here. So it is a prism inclined to HP. It is appears in the VP. So HP inclination appears in the VP. We already know that. And this prism is inclined to HP of certain angle, inclination. So either that inclination is given in terms of axis inclination or base inclination. Always in the problem they given axis inclined to HP, certain somewhat 20, 30, 40 or 50 angle. But here if you give an axis inclination, so it is easy to use base inclination. So you have to convert that axis inclination to base inclination. So if you want to find out the base inclination, we have to follow this equation. Base inclination is equal to 90 degree minus axis inclination. So in the problem always given axis inclination. So for construction we have to use base inclination. So if you want to base inclination, so 90 minus that axis. If axis inclination is 45, so 90 minus 45, it is 45. So take base inclination as a 45. So first base inclination 45 and construct this and go for the further construction. So next point to be discussed is some special cases. In some special cases means it is a prism, okay. But in case of pyramid, instead of this HP inclination, they given this edge or this face is resting on HP. Means in the second position they won't give any inclination. They won't give inclination for HP. Instead of that, this edge, this slant edge is resting on HP. So that is the special cases. In that cases, see, here I explained it's a pyramid and this edge is resting on HP. It is in second position. Here not given any HP inclination. Okay, and after that the last third position we already know that it is a reconstruction position. So here we have to go with either two methods. One is normal method and locus method. Locus method always beta angle only, because there is no alpha. Alpha angle comes when the resting on VP, but here resting on HP, so that we have to go with the beta angle. So here when the solids or pyramid given with the axis inclination for third position, in the third position also the same axis inclination, then we have to go with the locus method. See, clearly I mentioned in the third position same axis is inclined for VP, then we have to go with locus method. But in the third position axis inclination is not there. Instead of axis inclination, if they give an edge inclination, then we have to go with normal method. See, I written one as a small example. The square prism, it's a square, it's a prism, okay. In the top it is like a square, and in the front view it is appears prism. And second position, it's the second position. Here there is a base inclination, means axis is given for HP, but we first find out the base inclination and a tilt given angle, then we reconstruct it. That is the second position, okay. But in the third position it is called as a reconstruction. Here there is an axis inclination. First you have to take this axis, okay. Axis is somewhat 50 or 60 mm. First you take the 50 or 60 mm and first draw that, okay, given angle. Given if it is a 30 or 45, first you draw that and draw a one locus line, okay. Draw one locus line, then take the second position axis. Take the second position, that is O1 to O distance, and from the O you just cut on the locus line and join, so that you will get a beta angle. On that beta line you are going to reconstruct this. You are going to reconstruct second position top view and projecting for upward, and you will get the final view. And here you can observe this is what the axis line, and this dotted line represents the hidden lines. So these are the three positions, and this is what some example of pyramid with that edge is rest. Here not given the inclinations. So with this we'll solve some problems.